Awesome, it's good to be here. Do you have me on audio? Cool. Thanks for having me here today. I'm really excited to be here. Thank you to the organizers for putting on this event. It was put together really quickly, and I think we've got a great venue and a great audience and a great group of speakers, and so I'm really honored and happy to be here today. So I'm going to be speaking about 12-factor serverless applications. Again, my name's Chris Munns. I'm a senior developer advocate for serverless at Amazon Web Services. Been at AWS again about 5 years now, across a number of different roles. And I'm actually traditionally an operations person. So I've done lots of rack and stack. I've breathed lots of clean, humidity-free air for many, many, many days of my life. I do not consider myself much of a developer. However, I am completely blown away by the possibilities of what serverless means for us as an industry, for companies that are adopting serverless technology. And before I held the role that I had now, I've really felt that it is going to be the future of where compute and building applications is going. So that's me. So why are we here today? So there's this concept that came out a couple years ago, and actually it was really cool to see Keith speak about a little bit of what he thought was kind of the history of modern application development. And he mentioned a couple of technologies kind of key to what I'm going to be talking about here today. And so there's this concept of 12-factor applications. Essentially, it's a set of rules or guidelines that represent best practices for building large, scalable applications. And it was actually kind of popularized by what people were doing with Heroku. And a number of people who were inside of Heroku building that platform helped kind of build out this concept of 12-factor. So I'm curious here, how many of you have heard of 12-factor applications? Cool. How many of you try to follow the 12-factor guidelines, whether you actually think about it or not? Okay, a couple of you. Cool. So part of what I want to put on this talk is in my current role here at Amazon Web Services, I hear from a lot of people that ask me questions around, Chris, what are best practices for developing serverless applications? What do I want to think about? How do I want to think about structuring various different things? And I think there's a misconception that serverless means that there's such a drastic shift in how you think about building and scaling applications. And while the process of working with certain technologies like AWS Lambda, which I'll talk about here in a little while, is different, realistically, a lot of the kind of stable best practices that we've had for a number of years, popularized by things like 12-factor, continue to hold true. So you don't really have to throw out all of the things that you've known for a number of years and start from scratch as a developer. In fact, a lot of these carry forward. And so, again, the 12-factor guidelines have again considered best practices for both developers and operations folks, and so we'll talk a little bit about that. Many of them align directly with capabilities in various different functions as a service or serverless platforms that exist today. However, there are a couple that don't, and there are some that are interpreted a little differently. And so that's kind of the overall agenda or talking topic for today. So let's talk a little bit more about what 12-factor is if you're unfamiliar with it. So you can go to the landing page for this, which is 12factor.net. This is actually just kind of a screenshot of this, and basically it walks through what the idea is behind 12-factor, why it exists, and why it's important. And I'm going to highlight just kind of a couple of key aspects of this that kind of hit home to me as part of thinking about how serverless relates to it. And so in the introduction, kind of the second sentence here, we say the 12-factor app is a methodology for building a software as a service app that, and we'll go on these other points here. And one aspect of this software as a service part, I'm not sure if it necessarily matters in the case of serverless or even what you could do with 12-factor. And so I do find that it could apply for almost any type of an application, not just necessarily a software as a service application. And so a couple of kind of the overall guidelines. So one is use a declarative format for setup and automation. Talk about the relation to serverless with that. Have a clear contract with the underlying operating system. A little less pertinent in the serverless world that we'll be talking about today, but still a good kind of strong concept of a best practice. Suitable for deployment on modern cloud platforms. So I happen to be employed by a modern cloud platform. Many of you are probably using what would be considered a modern cloud platform, and we continue to see kind of growth in the industry in this direction. And so 12-factor aligns very, very closely with cloud. In fact, I think you would struggle to a degree to be able to follow the patterns of 12-factor if you were doing this on a on-prem, physically owned data center versus using a real true cloud platform. We want to minimize divergence between development and production and enable continuous deployment. So I spent about 18 months of my time here at Amazon Web Services focused on the DevOps space, where I talked about continuous integration and continuous deployment almost every single day. I find that probably 8 out of 10 or 9 out of 10 organizations spend way too little time focusing on actually doing CI and CD right. Many organizations, some number of that probably aren't even doing CI and CD. But realistically, the best practices for having a high web scale, high scalable, stable, well-performing application start before that application hits production. And there's a kind of a famous saying out there, many people have testing environments, some are lucky to have them also not be their production environment, right? So we want to think about that best practice of having those separate environments. And again, 12-factor encourages this, and with serverless, it's also very key. And then lastly, the aspect of being able to scale up without significant changes to tooling architecture or development practices. And I think what we've seen is over the years, some of the biggest companies in the industry, Keith talked before about Twitter and Facebook, they have seen as they've had to scale that they have had to make technology shifts. They've ripped out languages, they've ripped out whole different technologies in terms of databases that sit inside of their architectures. And so realistically, what we want to try to do today is find technologies that will help us reach a very massive scale before we would have to do that. And actually, both Twitter and Facebook use what I would consider to be boring technologies up through the tens, if not hundreds of millions of users. And so can we think of the things that will get us there before we have to worry about these billion-dollar problems? And I think with 12-factor, that's very much possible. So that's kind of the view into what 12-factor is. Again, kind of broad best practices that relate to modern software applications, typically web-based, with the idea around scalability and, again, things like multiple environments and recreatability and clean contracts. So next, kind of another big topic in the room, and one that I'm sure I could come to fisticuffs in a verbal sense with other people on, is what is serverless? And so we at AWS have a pretty firm definition of what we feel serverless is. The first one is no servers to provision or manage. So if you're looking at something and it calls itself serverless and it says, here's how you install it on your server, right away you want to question the meatless hamburger, right? What exactly does that mean? If you're installing software, then you're probably managing a server. Should scale with usage. So basically, as requests come in, you should automatically have that be able to handle the serving or the response to those requests. Should never have to pay for idle. So being able to scale with usage, but having tons and tons and tons of unused resources around doesn't really help you from a financial aspect. And so one of the key aspects of serverless is that there isn't a concept of idle, there isn't a concept of capacity planning that you should need to put really thought into for things that we consider serverless. And then lastly, availability and fault tolerance built into it. So it wouldn't be good if you had some sort of technology, and it had the first 3 features, but then didn't have things like availability and fault tolerance built into it. And so for us at AWS, we have a concept of regions. Inside of regions are availability zones. And when we talk about serverless products, we talk about those that automatically span availability zones, providing high availability and fault tolerance for you. So you should never have to think about an instance in one AZ and an instance in another AZ as an example. And again, for us here at AWS, the core of this whole serverless space is AWS Lambda. So Lambda was first announced and launched in November of 2014. Then it went into, as a beta, it went to GA in kind of spring of 2015. So we're coming up here on the 3-year mark of what Lambda is. And so Lambda is a event-driven function-as-a-service compute product that is serverless. So it meets the 4 guidelines that I mentioned before of you don't manage any servers, scales automatically, you don't pay for idle, high availability built in. And kind of the model of what we consider a serverless application is you have an event source that then goes and triggers a Lambda function. That Lambda function runs your code, which does whatever business logic it is that you might have. And today we've got 4 kind of main languages that we support, so Node.js, Python, Java, and C#. But what the community has done is built tools that use one of those 4 languages to launch things such as Go, Smalltalk, PHP, Ruby, I think Swift, kind of almost anything else that you could think of. So that's kind of big view into what a serverless application is. In terms of Lambda and common serverless use cases, it's going to be almost anything. So there was a comment earlier about what is or what isn't a good fit for serverless, and there is a line there, and I think we're pretty upfront about things that we would say, hey, this maybe isn't the best use case for something like Lambda. But if you're building any of the kind of 6 categories of things that you see up here, these are actually really good use cases for Lambda. So web applications, backends, things like microservices that exist inside of your infrastructure, data processing, things like stream processing, batch processing, chatbots growing increasingly popular for things like sales support, customer support, internal tooling. Amazon Alexa, so there's now, I believe, over 15,000 Amazon Alexa skills that are out there. A good number of those are actually powered by Lambda and serverless architectures. So a really cool way to kind of play if you happen to have an Echo device or any sort of Alexa-capable device at your home, you can build a skill. So if you happen to have any kids or nieces or nephews or an easily impressed significant other, you can make yourself a nice skill that says something like, Alexa, who's the smartest person in the house? And Alexa can come back and say your name. So give that a try if you ever want to impress somebody. And then lastly, IT automation, which is how many people actually dip their toes into using things like Lambda. So building glue capabilities across different services. We now have a service called Glue. I'm not referring to that, but more like things that trigger off of events inside of your infrastructure or get called by other services. So that's kind of the view that we have into serverless, and Lambda, again, kind of being at the core of what serverless means to us here at AWS. So let's go back to the 12-factor concept here real quick. So 12 factors, 12 kind of points that we're going to think about. I'm going to go through each one of these here today, hopefully before I get the hook on the stage. Codebase, dependencies, config, backing services, build, release, run, process, port binding, concurrency, disposability, dev prod parity, logs, and admin processes. And as you're reading some of these, you might think, you know what, I can already kind of guess at which some of these may not be relevant to what we're going to talk about, but we're still going to kind of go through all of them. And some of them are pretty quick and easy. So first one here, Codebase. 12factor.net tells us that one codebase tracked in revision control, many deploys. And basically how this relates to things like serverless apps is the idea that we, first of all, should all be using source control. So source control has been made a incredibly easy resource to consume today, whether you want to use GitHub or GitLab or Bitbucket or Code Commit or any of the various tools that are out there in the world today. The idea that all of the code that you have related to an application should be stored in revision control. And the idea here is that from that one code repository, deploys out to different environments, deploys over time, should eventually kind of come forth from this. One interesting thing about thinking about serverless is the bound of a serverless app. Like, what is it that sits and defines a serverless app? So kind of a general best practice that I have or like to recommend is if events are shared, so if you have a common event source, such as an API gateway, then any of the Lambda function code that relates to that single API gateway should all go inside of your same repository. If you have code that is spread across multiple event sources, so if you have code that maybe gets called by API gateway or Kinesis stream or S3 bucket notification, then you want to break those services into their own repositories. And now you might have shared code that exists across those, and this is where you would want to lean on some sort of packaging technology for dependencies inside this code base. And so we actually do see this pretty often in places where companies have very shared business logic across very different Lambda functions. You don't want that shared business logic to be basically the defining aspect of your code repository. It much more should align with essentially the invocation event source that aligns with your serverless application. And so I just talked about code dependencies. This is actually the second factor in 12-factor applications, is the idea that you should explicitly declare and isolate dependencies. So again, code that needs to be used by multiple functions should be packaged into its own library. This is a general development best practice that we've had for going on probably 2 decades or so now. So, if you have code that's going to be reused, you don't want to copy and paste it. You don't want to have to potentially have some sort of hard linking behind or between code repositories. And so what we have across the major languages that are supported by Lambda today are a number of different capabilities that are just inherent in those languages for you to bring other code with you. So for Node.js and Python, using things like NPM or pip packages. For Java, you can pull in packages from places like Maven, and from C#, you can pull in things like NuGet packages. And so all of these can then be included in your code to help greatly reduce the amount of code that you're writing. And then obviously you can create these yourself for any sort of shared business logic or capabilities that you have. Again, kind of streamlining the code that exists inside of a given repository and keeping them much more highly independent. So cool, 2 factors in, still all makes sense. Third factor around config. Store config in the environment. And this is a big one actually that folks like Heroku really pushed for a long time in terms of how you pass in configuration parameters into their platform. And we've seen a number of other technologies that do the same thing. So inside of things like serverless applications with Lambda, we've actually got a couple different ways that we can do this. One is via the native environment variables that exist inside of Lambda. So with a given Lambda function, you could pass in essentially key value pairs that get picked up the standard way that they would in the language that you're using for your function. So depending on whatever languages that you're using, they have the ability to call essentially environment variables that live at, you could think of kind of the OS level, into your application for everything from true like configuration parameters, secrets, so database, passwords, keys, API keys, things like that. People use them for things like A/B testing parameters. And so there's a number of different things that you could do with the concept of config parameters inside of a function. API Gateway also supports something similar. In this case, they're called stage variables. Same concept, key value pairs can be passed down into your application, lots of capabilities. And then more recently, Systems Manager has become a really cool option for people that are building or looking for this kind of capability in their application. And so Systems Manager actually gives you a ton of capability around managing things like configuration environment variables. Supports things like hierarchies, plain text or encrypted with KMS. And I should have mentioned that Lambda supports encrypted environment variables also. Notification of changes can be passed out, secured with IAM, captured in CloudTrail. And it's actually really easy here. So on your right-hand side of the screen, you see kind of a code snippet where I am using basically the Boto client in a Python Lambda function to call into Systems Manager parameter store, get the value that I need, and then go ahead and make that available inside of my code. And so centralized way for controlling access to these secrets, these variables, et cetera, that I need. When it comes to choosing across the three of these, there's a number of different factors that you might think about, such as who is supposed to have access to them, how you want to keep on top of where they're stored and tracked and controlled. And so, there's, again, different ways to kind of scratch this itch. But you want to really think about, I think, looking at parameter store these days. There's a lot of really cool capabilities in it. So, okay, another factor, pretty much still on the same page. So, factor number 4, backing services. Treat backing services as attached resources. So what exactly does this mean? So basically, 12-factor defines a backing resource as anything that your application needs to talk to. A database, a queue, a storage bucket, a third-party API or another API or another service that you might be talking to. And so while they're not necessarily bundled directly into your application stack potentially, you want to think of these as something that is attached. So you're going to do things like pass in the connection strings for them, and ideally not have those things hard-coded into your application. And so in terms of serverless applications, no real differences here, right? The way that you build your applications with Lambda, when you talk to those backing services, it's effectively the same thing as it would be in any other environment that you are running an application. So from a Lambda function, again, you can call databases, queues, storage, other APIs, what have you. So pretty much exactly same thing in line here. Factor number 5, build, run, and release. And this is, again, another key one. So strictly separate build and run stages. And so the idea here is that the concept of your code base being compiled, being packaged, ideally being tested along the way across the various environments, which we'll talk about here in a little bit. And you really want to have kind of a common way of doing this that carries across all of those environments. You want the concept of a single build, but many deploys. So sometimes I've seen people in their CI/CD pipelines do a build of the code each step of the way. That's pretty risky because basically what it does is it introduces the potential for there to be variability between those environments, between those builds, and that's how you eventually end up with bugs in prod that you didn't see in staging your test. And so service applications, same concept, right? This is a general development best practice. And so whatever CI/CD tools you want to use, go forth and conquer. We have some tools here at AWS, CodeBuild and CodePipeline, that can make it really, really easy for you to go and do this. So real quick on CodeBuild, basically the way CodeBuild works, it is a managed CI service, if you will, that allows you to do things like build, test, compile applications. We see here an example of a buildspec.yaml file. This is essentially a text file that you could put inside of your code repository such that when you execute a build in CodeBuild, it will follow the instruction set that you see here across the 4 phases that exist. And so this is actually a really simple build spec for a serverless application. I'm referencing an input file, which is a SAM template, which we'll talk about here in a little bit, an S3 bucket. I've got my commands, so this is a Node.js related build spec file, so I'm going to do an npm install. I'm going to run an ESLint, so I want to do some linting to make sure that I don't have sloppy code. I'm going to then run some tests, so some local unit tests, and then I'm going to package up my application to be ready for deploy. And so basic simple steps here. I would do this once in my pipeline. What would come out of this is an artifact. That artifact would then get deployed up through services such as Lambda, and again, with the idea that my code has gone through some sort of process to help add assurance to me that it's been checked for issues, bugs, quality, and so forth. So from this would be flowing into something like CodePipeline. So CodePipeline is a continuous delivery service. You can see kind of an example here of what we'd consider a stage that has 3 actions in it. And so when you're building a serverless application, your workflow is you commit your code to your repository, you package or test it in code builds. You can then use CloudFormation actions in CodePipeline to deploy this application, making use of specific stage or environment variables, or of course you could again use parameter store. And then ideally we want to test our application between different stages, or maybe we've got manual steps that we have to do. So from a developer's perspective, this is a really basic code pipeline, 3 stages. Again, we've got source, build, and deploy. And all of this is like super easy to model out in CodePipeline with all the various tools that you need to have. Then what I have kind of at the bottom here is something that I call run stubs, and I'm actually going to execute a Lambda function to test the Lambda function. And so that's a pretty easy thing to do as well. And then we could expand upon this to make a production pipeline. So what I've basically done is take those original 3 stages, added 2 more on, where again in this case I'm pushing up through what we call staging environment, doing some more testing. Maybe I've got a manual QA sign off because I haven't fully automated my testing process. That's totally fine and totally cool. And then eventually I deploy this to production. So again, in terms of comparing this to 12-factor, build, test, run, straight kind of model here, right? All of this is just as possible, and you'd want to behave the same way with whatever CI and CD tools that you're using. So up next is process. 12factor.net says execute the app as one or more stateless processes. Good news, this is inherent in how things like Lambda operate. So Lambda is basically by default a stateless process. And you want to think of them as a stateless process. So there is a concept of container reuse. So a Lambda function essentially executes in an OS container. Those OS containers are kept warm for a period of time, so subsequent requests could go back to a previously used container. However, at any sort of scale greater than very minimal, you have very little assurance that you will ever end up on the same container. So there's no concept of sticky sessions inside of Lambda, as it were. And so while you could do things like use the temporary space for some sort of cache for data that you're processing, again, there's basically zero assurance that request 1 comes in and then request 2 comes in and goes to the same place. So treat them as stateless. Again, no promise of reuse. We might have a host that fails, and so your container goes away and we have to bring up a new one for you. And so make sure you're keeping state off of Lambda. So again, I've seen people try to get really creative about this. I've rarely ever seen it work out. But again, make sure that you're using a database and a cache just like you would in any other application, right? This is a general development best practice. It continues to hold true for Lambda. All right, factor number 7, port binding. Expose services via port binding. So in a traditional environment where we had an operating system and we had a network stack that was under our control, we would attach our application process to a port. Guess what? For serverless, this doesn't matter whatsoever. There's no concept of a port that you control. There's no concept of a network stack that you have much influence over. And what we actually, though, have in the case of serverless applications with Lambda is the event sources, which I kind of talked a little bit about before. And so, again, so instead of a port, you have that. So the various services or APIs that could trigger your Lambda function. With Lambda, there are essentially 3 different ways that you can invoke functions. Synchronously, asynchronously, and via a stream model. And again, there are different services that do that, or depending on how you use the API yourself, you can make that happen. And again, going back to an earlier best practice, instead of having one function support many different event sources, really have an event source per function model. and then reuse shared code as necessary. So port binding, not really interpreted the same way as it is in a non-serverless world for a serverless world. Again, in terms of these event sources, 3 different main models, async, sync, and then the stream poll model. And there's various different aspects of this. I'm not going to spend too much time on this slide. But basically, when you're building your application, let's say you weren't using a AWS source for executing Lambda, you want to think about which one of these is the right one for you. There are a lot of times when async could be completely fine, especially in things like in web page-based models where you're going to make a request to an API backend, and then maybe you've got JSON in your web page polling, looking for a change or for an end of an execution. That's great for an async model. You probably don't need a synchronous model for that. And so that impacts performance, it impacts timing, it impacts scalability. And so again, you want to kind of pay attention to these as you're building and designing your application. Here at AWS, we've got just about 20 or so different services that can invoke Lambda today. So we've got data stores, we've got endpoints, so things like API Gateway and IoT and step functions and Alexa, development management tools, and then event and message services, and we continue to see kind of awesome other integrations from other AWS services. So lots of different capabilities that exist here. There's also third parties that are now integrating Lambda execution into what they do. And so this list kind of continues to grow. So again, no such concept as port binding in Lambda. I've had people say things like, what port can I hit Lambda on? No port, you've got to go through an official event source. So concurrency, another pretty straightforward one, scale out via the process model. Doesn't really apply to Lambda again because Lambda is a naturally scale out based product as it is. You don't think about things like, again, individual processes. You can do things like fork threads inside of your functions, but realistically, you're much better off going across more functions than doing things like a ton of threads inside of an existing function. I've seen people have issues with things like ulimit saturation inside of a function where they basically do things where they say, hey, I'm going to spawn 2,000 threads inside of this function to pull in data from a queue. That's a really poor idea. You're much better off having many different functions that do a basic amount of polling than trying to have one mega function pull in a ton of data. So again, doesn't really quite apply the same way as it would in a traditional application. Disposability, another one that doesn't apply directly the same way. So 12factor.net says you want to maximize robustness with fast startup and graceful shutdown. Well, the second half of this doesn't apply to things like Lambda at all. So there is no concept of a shutdown that you have to be concerned with. With Lambda, you basically care about your function for the duration of execution. So your request comes in, a container either exists or doesn't, it executes, and then basically as soon as your callback comes, you no longer really care about what happened to that compute resource. So there's no real shut down this process, shut down this container, scale down an instance type of a methodology. But what you do care about, though, is startup speed. So when it comes to maximizing robustness, startup speed, which is actually a factor of a couple of different things, is something that you really are going to want to be concerned about. So, kind of some basic math around this is, the factor of the deployment package size, the language that's used, if you're in a VPC or not, virtual private cloud, and if you have pre-handler code calls. And so deployment package size, keeping it as small as necessary is always good. Again, this is where reusing things like dependency packages inside of your code, keeping your deployed functions related to a single event source such that it helps keep that deployable package really small is really key. Language used. So compiled languages take longer than non-compiled languages. That's a factor of what it takes to fire up a process for a compiled language versus one that's not. Now, this is a problem that's more on our side that we're trying to help find improvements for, but there's a lot of different data out there that shows that Node.js and Python is going to be faster than Java and C#. Doubly so if you're launching one of the other languages that exist through a shim. So for example, if you're going to do things like use the Sparta framework to launch Go inside of Lambda function, you're paying for, to a degree almost, like double overhead as part of that. Now, it doesn't work out exactly to double from the mathematical standpoint, but again, you want to think about all of these. And then pre-handler code calls. So inside of a function, you basically have code that exists before your handler, and that gets executed on container start time. So the first time that we start a container, you could do a bunch of different things. There's actually a lot of really good reasons for having code exist before the handler. So I talked before about parameter store, pulling in environment variables for you. That's a great thing to do before the handler. Things like establish, say, a database connection to a relational database. That's a great thing to do before the handler. Things like pulling in, say, other libraries or other data from S3 that are not pertinent, say, like an invocation. Great thing to do before a handler. But beyond that, you want to be really cautious about having a ton of code that gets executed pre-handler, because all of that has to be executed before your function's handler can be executed. And again, that's going to apply to that startup time. Factor number 10, dev prod parity. Again, a really straightforward concept that a lot of people don't really pay enough attention to. So keeping development staging and production as similar as possible. This factor applies no matter what technology you're using. Especially for, just the same as it would for serverless applications. And so this can be made really, really painless via using things like environment or stage variables or parameter store to basically have different parameters per environment. So again, don't hard code values such as databases inside of your code. Make that something that's passed in as part of a config. Again, that applies back to that 12-factor piece of guidance. You can use various tools for deploying your application. So we have a tool called Service Application Models, or SAM, which I'll talk about here in a moment, that helps make this really trivial for you. And then again, having a CI/CD process and tooling that supports multiple environments or accounts is really key. So again, your CI/CD process is not you ran local unit tests and then you deployed from your laptop. Your CI/CD process is that you have a true continuous delivery tool that is capable of knowing about different environments or different accounts, and you have effectively what would be considered a pipeline that pushes your code through those. So do understand that a concept of a local CI/CD workflow is kind of a misnomer in this case. So again, this factor applies directly the same. So real quick about SAM. SAM is our little squirrel friend. Again, SAM stands for Serverless Application Model. For those of you who are maybe newer to Lambda, who maybe haven't seen this, SAM is a tool that we launched back in the end of November last year. It is an extension on top of CloudFormation that helps make it really, really, really easy for deploying serverless applications. And when we say serverless application, we mean an event source, your function, and then even potentially the resources that function is talking to. It has kind of three, what I'd consider kind of like streamlined resources inside of it: functions, APIs, and tables. However, it can support anything that CloudFormation can support. So recently, CloudFormation got support for parameter store. So you can actually put your parameter store information inside of your SAM template such that it can define your hierarchical structure and things like that, and have all of your application knowledge inside of that same template. You can do things like define an RDS instance inside of your SAM template. So all these things kind of cross over. And you could find this up on GitHub. It's an open specification, Apache 2.0 license thing. We're always looking for basically like samples of SAM templates, documentation cleanup, and there's continues to be kind of more stuff going on there. So a quick example of a SAM template. This is a very basic SAM template. What it has is a single, or technically two resources, a single serverless function resource, and then what's called a simple table resource. And I won't expect you to read through this whole thing, even though it is pretty short. Basically, three sections, more or less, to this. The first is the headers. The second line there is the most important, the line that says transform. This tells CloudFormation that it needs to basically do some introspection on this template to extrapolate the simplified resources into something more. Then I have, again, my serverless function. So we can see here it has the code URI, so where my code lives. It has the handler inside of that code, the runtime for the environment, policies, and I can have a managed policy listed here. I could expand out a full policy document. And then an event. So my event is called getHTML. It's of type API, and it has the following properties. This roughly 12-ish lines of code creates a Lambda function for you, creates an API gateway stage for you. It creates the Lambda execution permissions, it creates the invocation permissions, glues everything together, takes your code, puts it up on Lambda, and basically automates that whole process of configuring this for you. So really, really, really streamlines what's necessary to configure an application. And then down below here, list table. This actually defines a DynamoDB table with if you just do these two lines, it gives you 5 read and write units. Now that DynamoDB does auto-scaling, so we do consider DynamoDB now to be a serverless database. This is all you really need to get started with Dynamo. You don't have to think about any sort of kind of complicated capacity planning as part of setting it up. You could pass in things like environment variables to SAM templates. So inside of CloudFormation, there's a concept of parameters. Parameters can then be consumed inside of your resources. So you see kind of on the left here, my parameter definition, and then on the right, or yeah, your right-hand side, in the blue, those are the resources for Lambda and API Gateway. So SAM, again, really easy way to kind of quickly define your serverless stacks. Just about 3 weeks ago, we announced something called SAM Local. So SAM Local is a local CLI for testing your Lambda functions. Basically what and kind of all sorts of different things about it. So works with both Lambda functions and what we call proxy style API. So it does actually create like a mock API interface local on your laptop for you. It gives you kind of all sorts of logging for the response object, for the function logs. Today we support Java, Node.js, and Python as part of this. C# is coming. We are working on that. Supports live debugging for Java and for Node.js. And basically what it does is when you're inside of a code repository that has a SAM template in it, it will go and take that repository, throw it into a Docker container, so you have to have Docker installed locally. That Docker container is based off of one that is the exact same environment as we run in AWS for Lambda. So it's an Amazon Linux Docker container, contains all the things necessary for you to execute your Lambda functions inside of it. And then again, be able to call it, be able to throw things like mock event invocations at it. You can do things like validate your SAM template. It's a pretty cool tool. This is open source. It's written in Go. The team is actively accepting pull requests. Came out just about 3 weeks ago. It's been trending on GitHub for, I think, most of the last 2 weeks. And so please do check out SAM Local. So coming in around the end here, factor number 11, logs. Treat logs as event streams. So you have a concept here at AWS around serverless and things like Lambda that monitoring and logging are a universal right. Essentially, they are deeply ingrained in the product. It's not something that you optionally toggle. And so with Lambda, we capture anything that looks like console.log. Again, depending on your language, we capture certain aspects about the runtime, the invocation for you. However, you can just as easily go and create your own using, again, just generic output from console.log, but if you want to capture various metrics, you can just use the CloudWatch SDK. And then things like metrics and logs get streamed into CloudWatch metrics or CloudWatch logs. And so you could actually do basically like stream processing against them. You could take them and throw them into things like S3 or Elasticsearch, whether it be Amazon Elasticsearch or your own. I've seen people take them, put them into S3, and then toss them into things like Loggly or even Splunk or something like that. And so same kind of concept, logs, incredibly important, as well as metrics. And then the 12th factor of our 12 factors here, admin processes. Again, one that doesn't really quite apply the same way. So run admin or management tasks as one-off processes. Doesn't apply to Lambda. Pretty much anything you do is going to be a one-off process, as it were. So again, based on the compute model with Lambda, this doesn't really apply. Any sort of administrative task that you had, you could do via just another Lambda function. If you need to interface with, say, like an EC2 instance or a server somewhere, you could use things like the EC2 run command, which effectively runs a daemon on a host and can execute commands for you. So we've gone through all of our 12 factors here. Again, some that apply, some that don't. Basically, what we end up with is kind of 7.5 of them that directly apply to serverless applications the same way that they would for what we'll consider server-full applications. So again, Codebase, dependencies, config, backing services, build, run, release, the first half of disposability, so quick start, dev prod parity, and then logs all pretty much work exactly the same way as you would want them to. Whereas process, port binding, concurrency, and admin processes really just aren't applicable to serverless. So basically, you only really need to care about, again, 7.5 of the factors if you were going to follow this. So kind of rounding this out here in closing, again, we've gone through the 12-factor guidance for building a good, strong, web scalable application and architecture. Some kind of key concepts that come up again kind of over and over again, right? So think about code reusability and how to scope your functions to the smallest size necessary. Again, it impacts so much of basically what a lot of people have talked about here today, right? The speed of time to market for your functions, keeping them fast and nimble, reducing kind of the time that you have to spend debugging based on reducing complexity in them. That's a really, really key thing, and I think it actually comes up in many of the conversations that I have with developers about serverless. Factors related to things like process management, network ports, concurrency, admin processes just don't really apply here because of the way that Lambda works, right? So things like Lambda, the various other managed service products that come out from Microsoft and Google and IBM really don't have these kind of concepts in them. So luckily, you just get to kind of take those out of your mind when you come to building serverless applications. And then again, because the best practices for serverless align really well with 12-factor, minus the 4.5 that you don't care about, just by building a serverless application, you get a lot of this stuff right out of the bag. So building serverless applications kind of guides you towards best practices versus if you were just building something on an OS or in a container. So we've got a lot of content out there, including best practices docs, instructions, getting started, reference architectures, code in GitHub, blog posts, videos, webinars, et cetera, that you can find off of the landing page for serverless at awsamazon.com/serverless. We also recently added another page onto this for developer tools. So we've got all of our developer tools, all the major frameworks that we see customers using that are friends of us here at AWS Lambda, CI and CD tools, all sorts of other things that you might want to take a look at. Again, my name is Chris Munns. I'm a senior developer advocate for serverless, part of the API Gateway and Lambda team actually at AWS. You can get me at munns@amazon.com. You can find me at Chris Munns. And with that, I'll be here for the rest of the day. Happy to take questions, probably in the back because I think the next speaker has to come up and get set. But thanks again for coming. I'm really happy to be here. Thank you again for the organizers for putting on this event. It's a great show, so thank you.